Next problem. 5 doctors each treatments for a certain disease and observe the number of days each taken to recover. The results are as follows. Recovery time in days. Discuss the difference between A doctors and B treatments. So here total number of items in the given data n is equal to 25. Number of column, that is treatments 5. Number of doctors row, that is equal to 5. Define null hypothesis H naught. There is no significant difference between the treatments. Similarly, there is no significant difference between the doctors. So alternate hypothesis, there is significant difference between treatments. There is significant difference between doctors. Now we are going to shift the origin to 16. So subtract 16 from each and every numbers given in the data. So you will get the new data, which we are going to use for ANOVA calculation. So 10 minus 16, 14 minus 16, 23 minus 16, etc., etc., 22 minus 16. So you will get the new number minus 6, minus 2, 7, etc., etc. Last one 6. Now prepare the calculation for ANOVA. Doctors A, B, C, D, E, and treatments 1, 2, 3, 4, 5. So first the datas. So after shifting, we are getting these numbers. So we are taking that one, right? First row total 6, adding all the numbers in the first row. Similarly for the all the rows, 8 minus 4 minus 5 3. Similarly for the column, adding all the numbers in the each and every column, right? So first column total minus 30, second column total minus 11, 23, 4, and last column, fifth column total 25, 22. So now grand total. So either you can add row total or column total. So you will get the same number. It should be same, right? So G is equal to 8. Next Ri square by Ci. First one 6 square by 5, 7.2. Similarly for the all one, 12.8, 3.2, 5, 1.8. So sum of Ri square by Ci 30. Similarly column Cj square by Rj. So 180, 24.2, 105.8, 3.2, 96.8. Summation Cj square by Rj 410. Then sum of squares row. So squaring all the numbers in the first row and add. So you will get 114. Similarly for the all the rows 116, 90, 91, 63. Similarly for column, squaring all the numbers in the first column and add up. So first one 190, 31, 139, 12, 102. Then sum of squares, right? Sum of squares, all the sum of squares, right? Sigma xij square. Either you can add row side or column side. Both should be equal only. So summation xj square is equal to 474. That is SS, right? So now you have to calculate CF. CF is equal to G square by N, that is equal to 2.56. So here SS is the this one summation xij square. Note that, right? We are going to use in that TSS, RSS, CSS to find, right, all the values, right? So first TSS, SS, right, minus G square by N, that is equal to 471.44. RSS, that is equal to 30 minus 2.56, 27.44. CSS, that is equal to 407.44. ESS, that is equal to TSS minus CSS plus RSS, that is equal to 36.56. Then ANOVA table, source variation, column row error. Sum of squares CSS 407.44, RSS 27.44. All the details are here in the above, right? So in the above lines you are getting all the details, right? And ESS 36.56. Degrees of freedom C minus 1 4, then R minus 1 4, and V3 R minus 1 into C minus 1, 4 into 4 16. Next mean sum of squares column. So you will get 101.86 for row, 6.86 for error, 2.286. Then F ratio for column. So MCSS is more than MESS. So that is in the numerator. Then MESS in the denominator. So you will get 44.58. Similarly for the row FR, MRSS is more than MESS. So write MRSS in numerator, MESS in the denominator. You will get 3. Next conclusion. So for treatments, so degrees of freedom V1, V3, 4, 16, right? Tabulated value for degrees of freedom 4, 16 at 5% level. Ft is equal to 3.01. Compare Fc and Ft. Fc is more than Ft, right? Clear. So therefore rejected. H0 is rejected. First one rejected. Similarly for the doctors. For doctors, degrees of freedom V2, V3, 4, 16. So tabulated value of degrees of freedom 4, 16 at 5% level from the table, right? Ft is equal to 3.01. Compare Fr and Ft. Fr is 3. Ft is 3.01. So Fr is less than Ft. Therefore, hypothesis 2, null hypothesis 2 is accepted. Thanks.